What's up guys, Richard here, welcome back to my channel. Today we're going to be building this isometric game. Now I don't have my camera because the battery's flat and I figured you guys really don't need to see my face anyway. So we'll build this character where you've got like the A movement, D, W, S, and you can walk behind walls and you see this lovely debug red, and then you can engage this player and go into a perspective mode, and that's pretty much it. We will obviously over the weeks be building this out massively. Now the reason why I say over the weeks is because this is what we will be working on for this entire year's project. I'm working with an artist and a designer, and you guys will be following along in this devlog/tutorial series. This is going to be a learning exercise for both of us. Flax is brand new, hot off the shelf, lots of bugs to work around, but I like the challenge. So first up, open up a brand new project like this here, select the floor box brush, and let's just extend this out a little bit. Maybe let's make it 3 by, I was changing the center then. Let's make the size 3 by 3. There we go. So we've extended the floor out, lovely. You could probably move this over to the side, it really doesn't matter. Just put it somewhere. Anyway, the very first thing I recommend we make is probably the character. So we're going to go down to physics, we're going to grab a character controller, drag this into the world. Where is it? There it is. And I'll just name this player. Now, we need some visual representation for the player, so we're going to go up to basic models, cube, drag a cube under him. The cube obviously needs to be like more than 1 meter high, so I'm going to make like 1.8. And then in comparison, it looks like they're offset about the same, so, there should be with the new version of Flax as well. Front, view, by the way, I'm just testing out this new feature, back. Yeah, there we go. Okay, so I'm going to drag this and I'm going to pull it up, just get him off the ground. Okay, high DPI issues, another bug in Flax that we're still dealing with. Okay, so I'm going to put him down on the ground there, and there we go. Now, we're going to need some type of visual representation to show where he's facing. So I'm just going to add a secondary cube in here, and I'll just put this one under here, and we'll just name these things. So I'm going to call this body, and I'll just call this nose for now, just so we know where things are facing. So for the nose, I'm going to grab that, drag it out, and we're going to make this a lot smaller. So we go 0.5 by 0.5 by 0.5. There we go. And put that up there. Okay, cool. We've got our kind of player, what he looks like. First up, grab this camera, and we're going to remove this free camera script. In fact, we can come straight here and we can just delete that bad boy. We do not need it. Okay, now that we've made our player, which is good, we're going to actually put this camera into its correct positioning. So, the correct positioning for the camera I found was about 1000, negative 1000 by 900 by another negative 1000. Okay, now if I go focus on that camera, it's way up there. So it's looking now in the wrong direction. So for the direction, I'm going to put a 30 by 45. There we go. That is an isometric view. Oh, but the problem is this camera is currently in perspective mode. So I'm just going to turn off use perspective for the camera. There we go. That's actually zoomed in quite nicely. But if you wanted to make like that zoomed out a bit, you could change this orthographic scale to like 2. And actually, I'll leave it at 2. So now we're looking at that in the correct way. Okay, so first up, save your work regularly with Flax. You don't want to be dealing with crashes. Okay, so the next thing is we need a material for this. Now, you guys can probably do this if you're watching this video in a month, but I need to do a workaround because there's a current bug in the system. But what we would do is we'd go new, material, and we're going to call this player material. Okay, now, normally for this, I'm going to show you guys what you could normally do, probably in a month. Turn off depth test. Then go switch on full, and what we're doing is we're making a material that if you're behind the wall, then you can be visible by using that whole debug red. So we're going to need 2 colors. We go color 1 and then color 2, and we'll have red over here and we'll have green up here. Okay, so the red is going to go down into the true and the green is going to go into the false. And what we're basically going to do is, once I find the depth fade, we're going to say if you are close to a wall, okay? Wait, I gotta make that an equal. If you're close to a wall, your depth is basically gonna be 0, right? So if it's 0, then what I want you to do, if it's equal to 0, is show red. But if you're not, then I want you to show green. And this is basically a simple way of masking. But the next thing you need to do is change the blend mode to transparent and then slap this into color, okay? Now, if I put this already on the player, so let's just go straight on the player, press play. Notice how he's instantly red? That's because there's a problem with the orthographic camera at the moment. So if I go select my camera and I turn use perspective on, you'll notice he's green. So it works for perspective, just not with orthographic, which means that we actually now need to pull in a separate material, and I'm just gonna go grab that. For you guys, this will be in the download, so I'm just gonna grab it, and it's called the depth magic, and I'm just gonna drag this into here, and we're gonna use this one. I'm not sure why that's flashing up there. That probably just a random bug with Flax. Let me just save this. Yeah. Okay, don't worry about that. We'll just pretend that doesn't exist and apply that there and that there and there. It works fine now. But if I open this, okay, that flashing is going to drive me insane. I have no idea what's causing that. Okay, so we're back in and the material is no longer like doing that random flashing. I have no idea what that was about. So this is what we're going to use temporarily. If you guys want to use this in the meantime until that bug in the system's fixed, you can download it. It's in the description. So I'm just going to apply this to both of those things. Boom and boom. Should be good now. Great. That works fine. Okay, so the inputs in Flax, if you wanted to go mess with those, that would be under settings, and then you go into input settings, and then you would go into axes mappings. But we actually don't need to. We've already got the horizontal and vertical. It just comes with Flax, so that is fine. So what we're going to do is we're going to create a base script, because realistically we're going to have a player, and then we're also going to have an enemy, okay? So I'm going to go into source, game, and I'm just going to make a new folder, and I'm going to call this characters. And under here, I'm going to create a new C#, and I'm going to call this character base. Okay. Now, open up character base, wait for that to compile. Okay, that's compiled. Go into the game, characters, character base. Now, when we're in here, get rid of on-enabled, on-disabled. We don't need this or any of this stuff up here. So what we will need to know is a few things. First up, we're going to have a public variable that can be accessed from anywhere, and we're going to call this is engaged. And basically this means, is this character currently being engaged by another character or the player? This will be a base function. And then we're going to have a protected one, which will be for inheritance, and we're going to call this one actor focus target, and this is who he would be focusing on if he's focusing on someone. Actually, I don't think we need either the start or the update. Yeah, so I'm going to delete these as well, because this is going to be our base class. But what we do need in the base class is we need a get gravity function, okay? Because this is something that all the players are going to need, the characters and the players. So we're going to go protected, get vector3 get gravity. Now, the reason I'm not using just the built-in gravity, which you could access by going physics.gravity, the reason I'm not just doing that straight up is because I found Flax's gravity to be quite weak for what I need, so I always just kind of build my own. Maybe the devs will want to look into that, I'm not sure. Vector3 down, so we're going to get the down component, and we're going to times this by physics.gravity, and then we're going to times this by time.delta time, just to make it frame rate independent, and then go times 5. I just found 5 works for me. You guys can put anything you want in there. And one other function we're going to need to do is rotate actor A towards point B, okay? So we're going to need this for both characters and for the player, a rotate function. So protected void rotate toward, and then we're going to rotate player 1, so actor, and then I'm just going to call this actor A, towards vector3 point B. You could give it better names if you want. And you know what? We're going to add some speed in there as well. We want to be able to control the speed at which things rotate. This function can get a little bit complex, so I'll try and walk you through it. So first we're going to create a quaternion. We're going to call this start rotation, and that's going to be equal to a quaternion that comes from the rotation matrix of actor A's rotation. So we're basically creating a rotation quaternion based on the rotation matrix of the actor. And then we're going to make another quaternion. That was the start rotation. And then we want our target rotation. The target rotation is going to be the rotation towards that point that we just inputted. So we're going to go quaternion, and we're going to make a look at rotation. And we're going to look at point B. And we're going to look at that and give it a vector 3 up so that the quaternion knows which way is upwards to make that rotation. Only perform this rotation if the start rotation and target rotation are the same. So we're going to build in a tolerance because you can't just do a simple equal statement with quaternions. So we're going to access a quaternion function that's called angle between. And this is going to give us our tolerance check. So we're going to do an angle between the start rotation and the target rotation. And we're basically going to go, if that's bigger than 1, so that's like 1 degrees, I think. If that's bigger than 1, then we're going to basically do the whole rotate towards, so we don't waste cycles. So we're going to go quaternion, new rotation. Oh, why did I tab that? New rotation. And we're going to go, this is equal to a quaternion slurp. And the slurp is just going to do the smooth rotation of a quaternion. And we're going to start from the start rotation, then we're going to go to the target rotation. And we're going to do this over delta time. And then we're just going to make that based on the speed that's inputted. Okay, great. Now we need to turn this into a direction vector. And the reason being is because we want to remove both the roll and the pitch. You don't want your character like suddenly rotating down towards the ground. So I'm just going to call this Euler angles, and we're going to go new rotation dot Euler angles. So we're going to get that, and then we're just going to access this Euler angle, and we're just going to clear out the X, and we're also going to clear out the Z, and that will remove all the rotations except for the yaw, which is the left to right rotation. We want to keep that. Okay, once we've done that, we're going to make another quaternion. And we're going to turn this, and we're going to call this one updated first. Updated rotation. And this is basically just going to be this whole new rotation that's being corrected by removing those angles. So we're just going to go quaternion dot Euler. So we're going to grab that Euler we just created, and we're going to turn that back into a quaternion. Now the reason being is because I haven't found an easy way to actually turn a direction vector into the rotation matrix. So if there's an easier way, let me know, guys. So basically we're going to go actor A dot rotation is equal to the matrix function rotation quaternion, and we're going to take in that updated rotation. Okay, so that's pretty much all we need for character-based functions. Okay, so the logical thing to do right now would be to make the player movement script so that we can actually start testing this stuff. So we're going to make a player movement script. Great. Open that up. Reload all this. And while that's opening, you can actually just drag this straight onto the player if you've got them selected, player, and then add script. Great. Okay, let's go back into that. Again, remove on enabled, remove all this stuff, and we're going to start actually building this out now. So first thing, what we're going to need is something like a movement speed. Public float, movement speed is equal to 600. We're going to need a reference to the actual actor itself, its model. In the future, this would be the skinned model, but at the moment, it's just that cube. And then we're going to need our own versions of vector of the forward, right, and a heading. Now, the way to see how this works is if I go find, where's my camera? There it is. if I go select that camera and I look at this scene, the forward for the player is actually that way. So when you press the W key, we don't want you moving like that. What we want is you actually moving like this, okay? So we've got to be aware of that. Now I'm just going to reset that because I don't want to play around with those variables. Okay, so we need to calculate, therefore, our own forward, right, and heading. We can't just use the ones that are built in. So we're going to do this first. We're going to set this up in the start. So on the start, we're going to go... oh, we also need, by the way, while we're here, a reference to the character controller. So character controller, and I'm just going to call this controller, just so we can access all the stuff related to the character controller. So we're going to go controller is equal to this actor as a character controller. Great. Now, so we're basically just accessing the character controller itself and just telling, hey, cast me to a character controller so I can store a reference. Now, we're going to make our own forward vector. So our forward is just going to be equal to accessing a static function on the camera called main camera. And then we're just, well, it's actually like a static variable. Then we're going to access its transform and we're going to grab its forward. So now this will basically go, okay, I'm going to be this here, but I'm going to be the same as the camera, which means I'm probably going to look like that if I just implemented that straight in. But at least I'd be facing forwards based on what the camera is facing. But of course, we don't want that whole pitch involved because we don't want him facing down into the earth. So all we got to do is zero that out. Okay, and then we just normalize it just for safety. And that's pretty much it there. And then what we need to do is calculate our right, so that we know which way is our right vector. That's easy enough. You just grab the forward, and you times that by a Euler angle, which you make based on a quaternion. And you're basically just saying, hey, I just want to offset by 90 degrees. That's all I want to do. And that's how you get your right vector. So now that we've actually set the on start, we now need to actually do the player's movements. So in here, what we're going to do first is we're going to just do straight up a move player function. Now, which means that obviously I need to make that function. So I'm going to go private void move player. Okay. Now, in the move player function, first we need to get the inputs. Get the inputs. Now, first up, we'll go float horizontal. So this is the A and D input. We're going to go input. We're going to access the input system. We're going to get the axes for that. And we're going to get the horizontal. And that will get us the input for A and D. And basically that will always return it as like somewhere between like -1 and 1. And then we obviously want to get the W and S input. So we just do that, but we also change it to the vertical input because we didn't need to set up these keys. So just change that, vertical. Okay, now, next, what we want to do is actually check if a movement is needed. So we're going to go if horizontal is not equal to 0. That you should probably do a tolerance check here, but I found this works well enough for what I need. And if the vertical, that's basically saying, look, if some type of input has been inputted, then let's do something. We're going to go vector 3, and we're going to get the right movement. So this is how much they're pushing left or right. And we're just going to go, that's equal to the right vector that we created up above, times the movement speed, so how fast they should be moving, times the frame rate, and then times the actual horizontal input, the 1 or -1. So that's the right movement, and then we'll need a up movement. You could call this forward movement, but I call it up because it's kind of like up away from the player. So then we're just going to go forward, and movement speed time, and then just change this last one to vertical. Okay, so what we need to do, that gets us the, like, how much he's moving. It could be like 200 units or whatever, but we need to make the heading now. So this is the direction vector, it needs to be normalized. So we're gonna go grab the right movement, and we're going to normalize that, and then, or normalized, and then we're also gonna add the up movement, and we're going to normalize that. And just for safety, I'm going to normalize the heading itself. So we're going to go heading dot normalized. Good. Now, we have our direction vector. Now, all we got to do is apply this to the controller. So we're going to go controller, I want you to move. And I want you to move based on the way you're facing, the heading, plus how much you should be applying to your right movement, so your speed, plus the up movement. And then I'm going to, at the same time, get the gravity. Get gravity. Why can't I see get gravity? What did I call that? Let's go back to... Oh, okay. The reason I can't see get gravity is because I need to actually turn the player movement script into an inherited, like a derived child of the character base. So let's go character base, put that up there, and then if I go down here, I should go get gravity. There we go. That's what we were looking for. Okay, and save that. Now, if I save all this and I start playing this, it should actually work. So let's try. There we go. We have movements. So we've got A, D, W, S. Great. Now, first up, you'll notice, I'm just going to get close in. He was like way off the ground. So let's have a check how high he is up compared to the... Whoa. Oh, okay. What's happened here? I must have dragged it off. Oh, okay. I see what's going on there. Zeroed that out. Now, if we go... He's still very high up compared to the controller. Let's lower him down. Okay, let's go... Zoop. Yeah, he's still pretty high. I'm going to lower him down a bit more, and I'm going to grab the whole thing and just drag this up and lower him down a little bit more just for safety. Then we press play. There, that's looking better. Okay, great. Now, for the player, we're going to want to set the model straight up. So let's just drag the body straight into there just for safety. There we go. Now, the reason we're going to have this right here, this reference to the model, the body, is because we're going to rotate that in a minute, which is pretty much what we should do right now. So right now, we're going to handle the rotation of this character. So we want him to rotate towards the actual movement, like the way he's going. So the way to do this is we're going to go under move player, we're going to call the rotate towards, and we're going to rotate that model, and we're going to make it go towards the focus, not the focus target, we're going to make it go towards the heading. Because that's the way he's going, so that makes sense, and we'll make it at like 15. So if I save that now, go back in, and just wait for this to compile, press play, there you go, he's now rotating. So that's why we wrote that whole rotation script. Okay, great. Okay, so next what we want to do is have the... I guess we'll have this camera zoom in, but that should only happen once we have an enemy. So let's just duplicate all of this out. We're going to duplicate this body out, and we're going to drag it straight under the scene, and we're just going to call this enemy. So rename enemy. Great. So let's put the enemy just over here for now, and we'll rotate him just so he kind of faces. Let's have a look. Oh wow, that's really badly high. Okay, so I'm just going to grab him and push him actually in and put him on the ground for now. Yeah, that's good enough. That looks good enough. Okay, cool. So what we're going to do is we're going to make the enemy movement script. So we're going to go enemy movement script. Save this all. Just remember, guys, regularly save. You never know when Flax is just going to do Flax on you and crash. Still early days. Drag that straight on there. Okay, now if I go over here, it's going to ask me to reload all. And then for enemy movement script, straight up before I forget, we're going to go character base, because I want him to inherit certain functions as well. And I'm going to remove all of this as well, and we'll save that. Okay, so for the enemy, what we're going to need is we're going to actually need a collider so that we know when the player collides with the enemy. So I'm going to go over here, and I'm going to go under, I think it's under physics. Yes, sphere collider. I'm just going to drag that straight under enemy for now. Where is that? Okay, so it's really small. Let's just go 5 by 5 by 5. That's actually probably a little bit too big, but you know what? We'll just make it 3 for now. 3, 3, 3. Okay, great. That's good enough, I say. Now, this is called Sphere Collider. Cool. Let's go over here. We're going to need a reference to this Sphere Collider. So we're going to go public Collider, and we're going to call it sphere collider. So we're going to go sphere collider, and we're going to go as a collider, and then we're going to then go add a trigger. So we're going to go on trigger, I think it is. Yes, on trigger enter plus equal to, and then we're going to make our on trigger enter function. So we're going to make our own function called on trigger enter. So we're going to go void on trigger enter, and this is going to take in a physics collider. I think it's a physics collider actor. That's the one, and we're going to go collider. And there we go. We've got that function. Now, what's going up here? What is your issue? I'm not sure exactly what its problem is, but we'll find out later on. So we're going to go var player is equal to the collider, and from there we're going to go get script. So we're going to get a script on what we're colliding with, and we want to get the character base. And basically we're saying, hey, if I collide with something, and if that's the character base, so if that is valid, so we're going to go if the player is valid. For now, I'm just going to assume that that is an actual player. So we're going to go player on engage. Oh, I haven't written this function yet. So I'm going to go over to the character base, and I'm going to write a function. So we're going to go protected void on engage, and I think I'll probably need to pass something into that. Let me just check what I'm going to write here. So I'm going to go player on engage. What do I want to pass them? Actually, you know what? I want to pass them the actor reference itself. And then while I'm at it, I want to pass myself this same function, the on engage. And I'm just going to pass the actual enemy that I'm picking up on now. So I'm just going to go collider.as, and I'm going to go actor, just so I can genericize it, like to make it so that this function works across multiple actors. Okay, so that means then if I go to the character base, that means I need to take in a actor and call this other, I guess. Other works. Now, for the enemy movement script, I need to actually implement a version of this. Why is this wigging out? I'm just going to close this off. Close that, go file, recompile scripts. I feel like because I just changed the base class for this, it's bugging out. Cannot assign on trigger because it is a method group. Oh, I see what I've done now. I've said on trigger enter. That should be trigger enter goes to on trigger. Yeah. Okay, so I made a mistake there. My bad, peoples, my bad. Okay, so the actor himself also needs an on gauge. So I'm just going to go to the actor. I'm going to grab this, and I'm going to go player, and I'm just going to create a engage function there, just so that that will stop erroring out. So on engage, why are you not there? So player is coming in as a, what's that coming in as? Character base, and the character base has the protected void on engage. So I'm going to override this, and while I'm at it, actually, because I'm calling this from completely outside the function, that can't be protected. Which means if I go to the base class, I need to make this just a public function if I want to call it from the enemy. And that, yep, that sorted that out. Which means that this can stay as a whereas I didn't make one for the player, because it's just calling the base. So I'm just going to go to the base, and I'm going to copy this across, and now they all have on engage functions. Yay! So if I go debug.log, and then I can just go enemy engaged. And then I'll copy this straight across to the player as well. Public override void. So we've got cannot override inherited member because it is not marked virtual. Okay, base class public void. Okay, so we're going to virtual public void. And that is sorted. And that is sorted. Now if I go to override. There, that sorts that out. Sorry for that mess, guys. It's been a while since I've had to write just inheritance straight off the top of my head. Okay, so now that we've got that, if I save this and I go over to here, wait for it to compile, and then run it. Oh, okay, I did not set that as a trigger. So you want to grab the enemy's sphere collider and set is trigger. Okay, good. Boom. Let's have a look at the output log, debug log, object reference not set. Okay, let's see what we're having issues with. So we've got a warning, isometric enemy movement script 11. So if we go enemy movement script 11, sphere collider as collider, trigger enter, collider. Did I not set that? Okay, let's go to the enemy. Yep, I did not set that. Boom. Okay. Oh, okay guys, you're gonna want to not do what I just did just then. You want to set these things when you're not in play mode. There, okay, so let's try now. There we go, enemy engaged, but that second one should actually say, we'll just say player engaged, just so that's not confusing. Okay, so now that we've got that engaged all happening, the last thing we'll want to do is actually have the script so that the camera moves in towards the player. Okay, so this is going to be a bit of a script, and you're going to need to tap into one of my other tutorials if you want to use this. So basically, I'm going to make a folder here under game, new, and I'm going to go camera, because there's going to be a lot of camera stuff in the end. And I'm going to create a new C# script, and I'm going to call this smooth camera transition. Okay, now I have this script somewhere. Let me see. This is it right here. There is a video on my channel that's called Making a Smooth Camera Transition. If you want this script, you can either pause this video when you see me copy it in here, or you can go to that tutorial and get walked through basically how that entire script works, because I am not going to write that out now because that was a 30-minute video in itself. Okay, so now we're going to go make the camera movement script. Great. Okay, now if we go grab this camera here, this camera should probably actually be under its own empty so that we can play around with stuff. So what I'm going to do is I'm going to go grab a empty. So what have we got? Empty. I'm going to put this straight under here, but then I'm going to push this above, and that should, okay. Oh, this is going to be annoying. So negative 1,900, negative 1,000. So let's just go negative 1,900, negative 1,000. The reason we're doing this is because in the future, it's just going to get a bit messy if you've got everything just on that one camera. So we're going to have this and call this camera target. So camera target. Okay, now if I grab this camera, that should be all then zeroed out because we just want this to be at the same level as the empty. So that looks kind of fine, and 900, negative 1,000. Great. Okay, so that's in position. So select the camera target and drag the smooth, not the smooth camera, the camera movement script onto that, and then save, and then go down into here, reload everything again, camera movement script. Delete this and this. Okay, so first up, we're going to need to do some state tracking. So we're going to go enum state, and the states we're going to have at the moment is just follow and zoom. You would probably, like, if you first saw this, you'd be like, then why don't I just have one, like bool, and just turn it on and off? In the future, we're going to have multiple states, so I'm just future-proofing this system. I don't know why I keep typing private. I don't know why. Don't ask me. So we're going to have a reference to the scene camera. Then we're also going to have a reference to the player, because we're going to follow the player. Then we're going to have a reference to the player's camera, which I have not created yet. So let's go over, select the player, and under the player, we're going to add a camera. So we're going to go in here. Where would that be under? Visuals, maybe? Yes, camera. And I'm going to put that under the body for now. And let's go grab the camera, move this. Nope, we don't want it that way. We want to go back that way. We want it to go slightly there and then up like that, because we're going to kind of like go into a battle sequence. So we want to see our player in the left-hand corner. And I'm just going to call this follow camera. Okay, great. If I can spell, let's rename that. Follow camera. Awesome. Okay, so that will be the reference to the player camera. So I'll just leave that as player camera for now. We also need a reference to the character base. So we're going to go character base, and you'll see why we'll need this later. So we go player base. And then we're going to need a smooth camera transition, which is that script I just copied in. So camera transition. And finally, we're going to need a state. So we're going to go state current state, and that's going to equal to state.follow for now. Okay, good. Now, on the start function, what we're going to do is we're going to set a few of these references from internally within the system. So we're going to go player is equal to the scene, and then we're going to find the actor, and we're going to find the actor that's literally called player. Now, if you have a look, let me just double check. I called mine, yep, player. Now, normally I would use a tag system like Unity, but there is an issue with this at the moment, and the tag system's not complete in Flax. It's going to go up, it's undergoing an overhaul right now, so I'm just going to avoid that, and we'll change it in the future. So the camera then is equal to the player, so we're going to access that player we just got, and we're going to find the actor, and we're going to find the actor that's called follow camera. And then we're going to get that and store it as a camera, because we don't need it as anything else. Next, we're going to go player base. So the player base is going to equal to the player, but we're going to get the script on them, and we're going to get the script that's called the player movement script. Now, the reason I'm not getting the character base script directly is because I want to get the functions that are implemented by the player script itself. And then we're going to go scene camera is equal to just the actor itself, because this is on the target. This script is applied to this target here, but not the camera itself. And we're going to get child, and we're going to get the camera. So we're going to access the camera that's below it. And finally, we're going to create that smooth camera transition. So it's going to get equal to new smooth camera transition, and we're going to give it the scene camera, and we're going to give it the player camera, and finally we're going to give it a speed of 1 for now. You can play with that variable later. You can add in a whole heap of debug checks to make sure that none of these error out. If it works first time for me, I'm not going to add those debugs in. If I have an issue, I'll add them in. So let's do this. So we're going to go if, what is going on there? If player base and the player camera, so if both of these are valid, then we're allowed to do updates. So if something happens and one of these things breaks, don't attempt to do this update. You'll just throw too many errors. And then of course you can add your own error statements in there. I'm not going to bother. So we're going to go player base dot is engaged. And the camera, I'll check why that's erroring out in a second. Camera transition is not equal to null. So only do a camera transition if the player is engaged and the transition itself is not null. Now let's find out what's going on here. I can tell you what's going on here. I can't spell. That's what's going on here. Okay, good. That is sorted. So now we're just going to do a switch statement. And that switch is going to be based on the current state. And I hit tab so it just fills these out for me. Hit tab and it fills it out. Don't make a lie of me. Okay, cool. And I also noticed another spelling mistake there. Okay, so we've got our two states. We've got our follow and our zoom. So as soon as it swaps to, I think it's zoom. Yep. Okay, no, when it's in player state, we're basically going to go, do I want to do anything in the follow state? I don't think I want to do anything in the follow state. So we're going to go, this is set to follow at first. Oh, okay, so the first time it enters, so first time the player is engaged, it's going to come down here into the switch statement, and we're going to be set to follow already. So we're going to go then, camera transition. So I'm going to access my camera transition. Did I call it camera transition? Start transition. Oh, I did. Okay, so camera transition, I'm going to start the transition. This is my own custom function, which basically just builds out all of this stuff. Okay, so I'm going to start the transition, and then I'm going to go current state is now equal to the state of zooming, so that it will not go to this follow state again. And now I'm going to go access the scene camera, and I'm going to go, now I want you to swap to perspective because you're currently in orthographic. And then I could put a debug message in here, and I'm just going to go log, just to make sure it gets to this, and it says, start zooming. Great. Okay, then if you're in the zoom state, what we're going to do is we're going to access that camera transition again, and we're going to say, you, update your transition. Okay? And then that's pretty much it. And then of course, we would write a function that once it completes this transition and you complete your battle sequence, then zoom back out and go into the orthographic. But this video is all wildly way too long already, so I'm not going to bother with that. Now, let's see what's happening. So, enemy engaged, player engaged, nothing else is being called. That means there's an issue. So first up, let's check the camera. Did I add the script? Yes, the script is there. So let's just add a debug down here. Debug.log test. Let's see if any of this is actually being called. Now this should be called whenever the player is engaged. So if I go to the player, have I actually set up the, oh, okay. See, this is a mistake we've got. So we're going to go is engaged is equal to true. And then we're going to go focus at target is equal to the other. And then that means I should also grab the enemy movement and double check it. Okay, let's save that. So that was, because it wasn't engaged, it's not going to engage the camera. So it says enemy engaged, player engaged. I feel like that should have done something then. Let me just recompile those scripts. Every now and then things don't compile correctly. So I'm just going to compile it again. Nope, it's definitely not firing off. Okay, so we've got the player is engaged is equal to true. Focus target is equal to the other for the enemy. And that's equal to other there. So let's do some exploring and try and find out what's going on. So if we go into the camera movement, this is never being called. Let's go up here. Let's see if this is being called. If that's not being called, then that means one of those two variables actually just did not set itself. And I'll have to check those ones where I said I didn't want to do debug. So those are all being called. So that means that the player base and player camera is being called, which means that the transition, the camera transition is not being called, or the player base is not engaged. So I'm going to go, if, I'm just going to check this camera transition. If camera transition is equal to null, then I'm just going to go debug.log and go camera transition failed to create. Okay, save that. Okay, notice that there was never anything being called saying that it was created, so it failed. That means that this is not being created. Now, why wouldn't this be created? Maybe the scene camera or this didn't create. So let's put these both in here. So we're going to go boom, and we're going to go, where's the scene camera? This one here. And you know what? We'll just put all of them in here, just so that we know which one's failing. So we're going to go player camera, player base, and scene camera. So then we'll just change this to player base. I should probably have done this while I was building, but I just wanted to skip stuff. Scene camera, and then we'll go player camera, and then I know it's all just like failed to create, but all I'm looking for at the moment is just where the failure is happening. We can clean up the debug statements later. None of them are being called. Okay, let's just recompile again. Yeah, none of them are being called. Okay, that means this entire thing. But that's not true because we already did a debug down here. I feel like something else weird is happening. Wait up. Camera target. No, that's all correct. Yep, all of that is fine. I'm actually going to quickly close Flax. I feel like something's going on here. Okay, so I just quickly closed Flax. Let's press play and see if anything pops up. Oh my god, it was too. There was some random error with Flax. Okay, there you go, guys. So, yeah, just be aware of that. If something does not work and you think it should be working, maybe it was just Flax playing up on you. But yeah, there we go. We've got our movements, up, down, blah, 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 and then zoom in. Great. Okay, so we will continue the work on this in my next video.